Handling exceptions. All right, so errors happen within applications. No application out there is perfect. And even if you do have a perfect application, code is still running on the user's behalf. So if a user tries to access a file that they don't have access to, guess what? The code in our application is going to throw an error. And so it's our job as programmers to make sure that these applications can gracefully handle those unexpected situations. So that's what we're going to learn about in this nugget. Not only how to write error handling code, but I want to get you familiar with where to write error handling code, because you're not going to write this error handling code in every single piece of code in your application. That's just not feasible or even proficient. But the best thing to do is get familiar with what code could potentially cause problems, and I'll call that risky code. And the good example of that, as I just mentioned here, is code that accesses the file system because it's being accessed on the user's behalf. Code that accesses data in a database or any object in a database. Code that accesses resources on a network. All of this kind of code I consider risky code because, again, it's kind of outside of our control and errors can happen. So I'll show you some cool tips and tricks here in Visual Studio 2010 that'll help us identify what code could cause problems. All right, let's jump into the outline here and take a look a little bit more at what we're going to be covering in this nugget. We're going to start with an introduction to exception handling. I just want to go over, again, a little bit, give you a real-world analogy of why we need exception handling, what the try, catch, finally statement looks like. So we'll just start getting familiar with the syntax, and then we'll move into exception handling basics. And here I just want to get you familiar with writing error handling code and getting familiar with the construct, the try, catch, finally construct here, of how we can wrap code, handle errors, and catch them when they occur, and then look at the finally block for cleaning up afterwards. And then we'll look at how to work with exception handling. Here I want to give you a real-world example, a practical example here. We'll take our directory searcher, directory explorer application that we built in a previous nugget and used in a previous nugget, and we'll put error handling inside of it because right now it doesn't have anything in it. So in taking that perfect example there of a user accessing a resource on the file system that doesn't have permission and what to do in that scenario, I'll show you how to do that here inside of our directory browser. All right, let's jump in here to an introduction to exception handling and just talk a little bit about structured exception handling and what it's all about. So once again, exceptions, unforeseen errors that can occur during code execution. And again, this could be within our control, it could be outside of our control. A good example of within our control, something that I think is one of the most popular, error things that programmers cause themselves is casting issues. Casting. We're always casting from one data type to another, casting from, data that's stored somewhere into a variable that is of different data type. And you'll see this a lot with database applications too, where you're constantly bringing data from one format into another. And those are called invalid cast exceptions, and those you'll see all the time. So that's kind of one thing that we're in control of and we're responsible for, and you'll see it happen all the time. Outside ones we talked about, again, outside resources that we just don't have control over. Either way, they're still going to throw an error in both of those cases. And that's when you hear me say the word throw there. Exceptions are thrown. The .NET Framework throws exceptions when they happen, and I'll a little bit more on that in a second. You're like, throw? How does it throw an error? Do I have my baseball mitt handy here so I can catch it? Well, kind of. We're going to look at our baseball mitt here shortly. So we're going to do this here through the try, catch, finally statement. And this is why it's called structured exception handling. In the past, prior to .NET, it was just called error handling. And error handling was really just spaghetti code in the past. And what I mean by that is we would have something called an on-error go-to statement, where we would say on-error go-to at the beginning of our routines, and then when an error happened, it would just jump to that go-to label. Well, it's not structured at all. It was very spaghetti coding, and it just didn't look pretty. And but that was the old days. Now we have structured exception handling, and it's called this fancy term because it's a lot more structured through the try, catch, finally. Our try block is going to be kind of our risky code. This is where we're going to type in and try some risky code here, some code that's going to do something. Our catch block is if something goes wrong in the try and the .NET throws the error, we're going to put on our baseball mitt here and catch it. So the catch block is going to run only if an error happens. So as soon as an error happens on a line of code, it's going to immediately transfer down into our catch. And it's going to throw us an exception. So it's going to throw us this exception object, which is going to contain all of the details about the error that occurred. And this is where we get a chance to write some code to do something about the error. So we can gracefully recover from it here. If it's an error that we know occurs, that we're actually catching for a specific error, then we can do something about it. If not, maybe we can give them a nice error message, log the error, and then, instead of crashing the application, maybe abort the process or do something else. And the finally block is our cleanup code. It's our code that runs no matter what. So whether an error happened or an error didn't happen, either case, finally code is always ran. And let me, I've been trying to think of a good real-world analogy here that we could use to kind of sum up try catch finally. I think I found it. You might laugh; it's kind of silly, but think of a circus act or an acrobats or a high wire act, something like that, where they're always up in the air catching each other, flying around, doing crazy stunts. Well, usually there's a net below, and the net below is going to be our catch, and those crazy acrobats is our try. Well, what'll happen is they'll try their crazy acts, and if they fall, the net's going to catch them. Now, regardless, if they, and by the way, obviously we want to catch them because we wouldn't want them to go splat, just like we wouldn't want our applications to go splat, right? So that's the whole point behind error handling, is really to stop the splatting. Same with the net. So finally, think about the finally as the show's over and it's time to put the equipment away and pack up and move on. Well, you're going to do that whether splat happened or splat didn't happen. You're still going to clean up and put all the equipment away and move on, right? So that's kind of what finally is, and I'll give you some good examples here of why we would need finally. Alright, so as always, the best way to learn this stuff is by example. So let's minimize the whiteboard, head over to Nugget Lab, and get a demonstration going. Again, first here, I just want to get you familiar with kind of the syntax and the basics of structured exception handling. So let's hit start, head up to Visual C# 2010 Express Edition, and we'll fire up a solution I've got here called O5, Handling Exceptions. So first things first here, let's go into our console application. And we've got this program.cs here, and what we're going to do is we're going to take a number. We're going to say user enter a number, and then we're going to parse that number into your number and spit back out to them what their number is, right? So pretty straightforward. Now the thing is, this int.parse is kind of it could be an issue for us, because what if they don't enter a number? Well, something bad could happen. So that's what we're going to look at. In fact, you can tell that int.parse, if you hold your mouse over any method in here, you can see down at the bottom here, and this is a Visual Studio 2010 thing, really nice new addition here. Exception. See that? System.argument null exception, system.format exception, or system.overflow exception. What if they enter a number that's too big for an integer? These are some of the exceptions that could happen. And an argument null exception, you'll see in pretty much everything. That's really kind of our procedure here. Int.parse. You can't pass in a null value to parse. It needs a value. So that's kind of us as programmer thing to do. A format exception, though, the user could enter a bad value being not a number, and an overflow exception is they could enter something too big. So it'd be good to handle those things. And to give you an example here, if I hit Control F5 to run it, and let's just enter something like that and hit enter, check that out. Unhandled exception. System.format exception, input string was not in the correct format. And then it gives us the call stack there. So this is bad. See this? Looks a little familiar, right? This is what happens when you don't handle an exception. The program wants to crash on us, so we have no choice because we didn't handle it, but to hit close program there, and it's done. So it's our job to make sure that doesn't happen, and we can do that by writing some error handling code, and let's do that right here. We're going to put a try around our risky code. I hit tab twice here to get the skeleton thrown up for us, and what we want to do is just take this part. I'm just going to cut it out, paste it down here, and there we go. So this is our risky code right here. And in fact, we still want to take our console.write line and put it underneath it, because what will happen is if an error happens, it's not going to get hit anyway. It's going to jump right down into our catch statement. But if an error doesn't happen, we want it to run, and then obviously here, if an error doesn't happen, the catch code will not happen. It'll continue running right down here. And you can see by default here, it sets up a throw in here. We'll talk about that a little bit, how you can throw your own exceptions. But we want to handle this exception. In fact, this is a generic exception, so this will catch anything that happens in here. If we wanted to catch a specific exception, let's say the format exception, the one that we just entered here, we could put another catch in here. Let's do a catch, and in here we're going to do a format exception, just like so. All right, so, and you can have many catch statements in here, as many as you want. And it's good here, if you want to catch a generic one, then make sure your last one is exception, because it's going to try these in order. And then if it doesn't catch any of the ones that you're targeting the exception for, we'll create a generic exception object here that catches everything. And then you can put some logging code or anything else down here to handle a generic situation or a situation you're not prepared for. So what do we want to do when a format exception occurs? Well, we know that the user entered an invalid number, something that wasn't even a number, an invalid value. So let's just give them a message here. I'm just going to paste our message from above. And let's just say, not a number, please try again. Something like that, because we're handling this exception. Now, down here with this generic exception, we don't know what it is. We probably want to give them a little more information than, sorry, an error has occurred, right? And we can do this by making a variable out of this exception object. Now down here, we can reference EX, do a dot, and we can get information about the exception. So we probably want to send the message back to the user to get them a better idea of exactly what happened. In fact, let's just do a console. There we go. Console.writeLine, and just do an ex.message. That way they can get a message about the kind of the general object here, or the general error message that occurred. All right, so we've got a good start here. And in fact, rather than us restarting and stopping all the time, let's just wrap this around in a loop here. Let's do a while true, put a bracket up there, bracket down here. We just wrapped this whole thing in a loop. And what we're going to do is we're only going to break out of this loop if things are successful. So we'll put a break here only after they entered a valid number. So now we can do this. I'm going to hit Control F5 to run it. And let's just enter something that isn't a number. Not a number. Please try again. See that? And it's going to have us, we can keep entering all day long. Now let's enter something that's really big. Oh, see this? What this was actually our generic exception handler down here, because this isn't a format exception. This actually threw a different exception. In fact, if we do this, I'm going to stop that here. Just hit the X button there. If we do this, instead of doing an ex.message, let's do an ex.toString. This actually sends the entire exception object to a string here. So I'm going to do a Control F5, and let's just do that again here. Something really big. And there it is. There's the whole thing. Now it's not going to crash on us because we handled it, and we're just outputting exactly what it looked like when we do not handle it. See that? Value is either too large or too small. And look at that, a system.overflow exception. Well, that was one of the exceptions that was possible here on the parse method. See that? There's our overflow exception. So what can we do? Well, let's handle that one as well. Let's do a catch overflow exception. And let's just do our braces here. Let's paste in this and say not a valid integer. Please try again. There we go. Oop. Yeah, for completeness there. Perfectionist, what can I say? You know, I got to make everything look perfect. So that looks good. So we've got our format exception covered, we've got our overflow exception covered, we've got our generic exception covered, all wrapped in a loop. So let's hit Control F5, run this again. And now if we type in a string, not a number, please try again. If we type in something too big, not a valid integer, please try again. And let's type in something fine. Hey, your number is valid. Press any key to continue. So we've got all our bases covered with this code. And currently, this last exception will probably never get hit unless something crazy happens, because the only other exception that this could throw is an overflow exception, or excuse me, an argument null exception, and you can't enter a null value into this window. Good luck doing that, right? So you can try all day long, and it's just not going to happen. So, but there is one way to do it, and this is where throwing exceptions comes into play. And this isn't, any real value. I just want to show you how to throw exceptions, because throwing our exception inside of here is going to raise kind of a new kind of exception that will get caught inside of our generic exception block down here, because it's not going to be a format exception or an overflow exception. It's going to be our custom generic exception. So, and the reason you want to throw your own exceptions is if you're building middle tier components, maybe you're building a component that is a business is based on a business application, and you're writing your own business rules, your own validation tier. Well, you'd want to throw errors up so the developers that are using your components can handle them. Or maybe you're developing a data layer that does all the database access. Well, you'd want to throw your errors, throw your own custom exceptions here, or generic exceptions, so developers that use your components can handle them. So I'm just going to kind of give you an example of how to do this. Not necessarily a great way to do it, but it kind of shows the point nonetheless here. So let's do an enter the number between 1 and 10. All right, so if the user doesn't enter a number between 1 and 10, we're going to make sure that an exception is thrown, and because we're throwing it within our try, our generic exception handler will catch it. So let's just do an if here. Your num is less than 1, or your num is greater than 10. And let's just throw our exception. So just do a throw new exception, generic exception here, and you can see one of the parameters here is a message as a string here. Let's just say number must be between 1 and 10. Just like so. There we go. So now if we test this out with a Control F5 and type in 42, There it is. Number must be between 1 and 10. And in fact, that was our whole exception object to a string again here. If we did just a message, and then hit Control F5, typed in 42, there it is, just our message. Number must be between 1 and 10. Now, the only thing we're missing from this code block here is our finally statement. In fact, if we just add a finally down here, even though this is not a great place to do it because we don't really have any cleanup code in this case, but just to show you what finally does, let's just go down here and let's do a console.writeLine, and let's just say, thanks for playing. Something like that. There we go. Now, the thing is, finally, it always runs, error or no error. So what that means, see this break down here? You would think because we're in a loop and we hit break, that it would skip over finally and break right to the end of the loop and continue on. Well, that's not the case. Again, no matter what happens, finally is going to run. So this is a good test just to show you that we're going to do a successful run here. We're going to type in 5, for instance, which it'll bypass it won't throw an exception because it's valid. The number is valid, so it's not going to cause any of these errors, and it's going to say your number is valid, break, and then thanks for playing, all within the loop, just because finally is always run. So if we do a Control F5, type in 5, hit enter, there you go. It gives us our number, thanks for playing, and we're done. Now again, I'll give you a good example here in a second when we talk about how to actually do this in a practical application of where and a good implementation of finally. In fact, let's head over and do that now. So we're pretty much done here at the standard exception handling. You should kind of get the gist now of how exception handling works. Again, it's very simple. Just inside of your try blocks is the code you want to try. Have as many catches as you want. Try to catch all the possible errors that will happen within that risky code, and then handle them gracefully. If not, try to get a generic handler up there to at least output what the problem was. Maybe do some logging. And again, finally here, we'll take a look at shortly. So let's close out of this program.cs. Let's minimize or collapse, I should say, our console application. Let's get into our WinForm project here, because inside of here we have our directory browser. So let's take a look at some of the code that we're going to be working with here. If we go into the code behind for our exceptions form here, I didn't change any code since the last time we looked at this directory browser, so everything is the exact same. We have our get files button that we click that calls our get directory files, and this routine just, again, recursively calls itself to load up all the directories and subdirectories within a user-defined path. So right off the bat here, we've got this directory, get directories. And if you hold your mouse over it, you'll see some exceptions we need to be aware of here. The directory not found exception and the unauthorized access exception. So we need to handle both of those. And we can do that here. Let's do that right on the outside of everything. Let's just put a try right here. And we'll just wrap this whole thing inside of one big try. All right? And so we need to do a catch. And what are we going to catch? Well, we're going to catch a security or an unauthorized access exception. So if we just start typing in unauthorized access, there it is. And we know what we're catching here, so it's not like we need to send a message or anything. What we're doing is we're just going to take the background color of the tree node and highlight it red. So if we do a parent node, that's the node that gets passed in here, dot back color equal color dot red, that should do it. That should be all we need. All right, let's look at the code for this form. And to be honest with you, I have not touched a single thing inside of this code window since the last time we looked at the get directory browser. We still have our get files button, which just sets everything up, calls our get directory files routine, which is our recursive routine. In fact, just so we can get this all in one view, I'm going to minimize the text. Hopefully you guys can still see that okay. But just so we can kind of see everything in one shot here. All right, so we need to write some exception handling around our recursive function, because if we hold our mouse over get directories, well, we could have a directory not found exception, meaning the user typed it in wrong into the text box, or an unauthorized access exception if they do not have access to the directory, especially when they call a get files to get information out of there. And you can see there's also a security exception down here in get files. So let's handle these. Write some code to make this a little more stable here. We're going to put a try up here, one squiggly bracket up top, one down at bottom. There we go. It'll auto format it for us. And now what we need to do is put some catches in here. The first one we're going to catch is, how about an unauthorized access exception? So this is if the user does not have access to this directory. What we're going to do is, rather than give them any kind of big ugly error message and stop the process, we're just going to take the tree node inside of the tree view, the parent node, and turn the back color equal to red. Oop, typed that wrong. Dot back color equals color dot red. and that should be an equal, just like so. There we go. So we're not interrupting anything, we're just giving them visual notification that something is wrong. Now, on the case of a directory not found exception, we will want to notify them. So let's do this. Let's do a catch directory not found exception, and we're going to want to give them a message box on this one. So we'll do a message box.show, and rather than type in the directory is not available, just to save some time here, let's just see the, how about DNF EX, we'll call this, name of the variable for the exception, DNF EX dot message. Just give them the message, and that should do it. So far we've got the root set up here, and this thing's a little tricky when you talk about recursion because we've got loops as well, and when you have loops involved, you know we've just kind of got one big catch-all error handling, structured error handling statement in here. Well, but we could have other errors inside of here. So what we're going to do is we're going to put another exception block inside of here that wraps our recursion, and it also wraps our get files. And let's just do the same thing here. Let's just throw catch. How about an unauthorized access exception? And then this time, let's do the child node. So we'll do a child node.backColor equals color.red. All right, and we've got some fix that there for C# so it's happy, just like so. So if we didn't handle this within the loop, what would happen is if an error occurred within the loop, it would actually jump out of the loop, handle the error, highlight that node, and stop processing. So at least this way, it'll process the entire tree no matter what. And then we'll have some red nodes here, so the user will again have visual notification that something went wrong. So there we go. We've got some structured exception handling set up. We've got a nested try catch here. Now let's test this out. And in fact, in order to do this, we're going to need a directory that we do not have permission to. So let's go into the C drive here. Let's go into our test folder that we made in our recursion nugget. And in here, let's just say test 3.1. Let's take permission off of this. Let's strip it off here completely. So I right-clicked on it, went to properties, go to security, head over to advanced. Let's hit change permissions and uncheck include inheritable permission from this object's parents and remove them entirely. We're also going to remove everybody here. Now nobody's got access to this. And if we hit OK, and we hit, yep, only the owner will be able to change permission, sure. Hit OK, hit OK, hit OK, and there we go. Now nobody has permission to access this folder. All right, so let's test it out. If I hit play up here to run the application, let's just type in C:\test. That's the root directory, include subfolders, get files. There it is. See that? It couldn't go past 3.1 because we don't have permission to it. Highlighted it red, and we're all handled. And we forgot to test one more thing here. Let's just type in a bad directory. Get files. Hey, check it out. There's our general message box here that we made. Could not find part of the path. See? All right, looks good. So we're all handled down here. Let's move up to the top. And first we need kind of a generic error handler, because here's the thing. If a generic error happens down here anywhere that isn't one of these, what'll happen is it'll bubble up, the error will bubble up to the get files button, because this is where everything started. This is where the call stack started. And if an error isn't handled, it's going to keep bubbling up the call stack until it is handled, until finally it hits the root of the very beginning of the call stack. And if it's not handled there, that's when trouble happens. You get that unexpected error and a nasty error message, and the application crashes on the user. So let's create a generic error handler up at top. And we'll just wrap everything like so. Let's do a catch, exception, EX, and down here in our catch, let's just go ahead and give them a message box here. Message box dot show EX dot message, and that should look good for now, right? And this is also where the finally block comes into play, because especially when you have something like this could very easily be a long-running process where a user types in like C:\Windows and it takes forever to fill up the whole Windows directory here with files. So what we need to do is put a finally on here, and first actually let's give them visual notification by doing a cursor, and do this dot cursor equals cursors dot wait cursor. All right, so right away, as soon as I hit that get files button, it's going to turn the cursor into a wait cursor. Now, if an exception happens in here and we don't have a finally, and we don't actually turn our cursor back, they're going to be stuck on the wait cursor as long as our application is up. So this is where a finally comes into play, as it's good for this kind of stuff too here. Not only cleanup work, but for when you want to reset your visual interface or do something like this here with the cursor. Because right here we can reset the cursor by doing a this.cursor equal cursors.default. And that'll flip it back. So we're always going to hit the wait cursor, and now if an error happens or if an error doesn't happen, no matter what happens, we're going to flip the cursor back when this is done. So if we hit F5 here to run the application, let's just do that. Let's type in C:\\Windows, include subfolders, hit get files, and this could take a little bit, but you see the cursor there? So it's giving them a visual notification that the process is running. So if an error would occur, they would get the message box, and then the cursor would go away. If an error didn't occur like it did now, the cursor just goes away when it's done. And check it out. There is everything within this directory, or within the Windows C:\Windows directory, all the subdirectories, subdirectories within subdirectories, etc., etc. Now the other very popular use for finally is when you're accessing things like files, you can close the file. Accessing a database, you close the connection. So that way, if an error happens or an error doesn't happen, you close the connection. You know, a lot of times web services will have an abort process on it. If you're grabbing things from a web service, then you can call the abort process. So finally is great for cleaning up like that. Also, when you're creating objects up here above, you can destroy your objects and release them to memory. And again, we'll talk more about that when we get into object-oriented programming. But finally, is just that's why they call it housekeeping. It's kind of your cleanup area for cleaning up everything from this kind of stuff, visual interface stuff, all the way to objects, connections to things, so on and so forth. All right, so in the CBT Nugget, we took a good look here at structured exception handling and how to handle exceptions. We started off here with just a brief introduction to what structured exception handling is all about. I got you familiar there with the structure, kind of the syntax, why we need it, and then we jumped in and got a good brief demo on all the different things we can do here with basic exception handling, using the try to try some risky code, catching one or many possible scenarios that could go wrong, and then finally here for cleanup. And at the end I showed you a practical example how we could expand our directory browser application so it's a lot more stable now because it has exception handling built in. I hope this has been informative for you, and I thank you for viewing.